No? Okay. All right. So let's have a quick round of self-introduction. I'm Francesco Ellia. I'm a postdoc with a background in philosophy of science, and I work with now Tuschiya at ATR. Pedro?
Introduce myself. I'm Pedro. I'm a professor of mathematics at the University of Lisbon. My background is in physics and mathematics. I've been I helped found the Association for Mathematical Consciousness Science. So I've been getting involved in these things for some time now. And well, that's enough for now.
Ishan?
Hello everyone. I'm Ishan Singhal. I'm a postdoc at the University of Sussex. I work in Anil Seth's lab, and I come from a background in phenomenology and experimental design. So I'm usually interested in capturing aspects of experience such that they can be used to inform other aspects of the study of the mind.
Awesome.
Yeah.
Igori?
My name is Igor Comarovschii, and I'm doing my PhD project at Karolinska Institute in Stockholm, Sweden, and focused on neuroimaging and connectome-based modeling in Parkinson's disease. So I have background in medicine, in neurology. Now I'm doing the research and also interested in general in in network science and neuromorphic computing, for example, as well.
Awesome. And Luis?
Yeah, I'm sorry about that. So my name is Luis. I'm an assistant professor at the University of Navarra in Pamplona, and my background is in cognitive neuroscience. I'm just getting into this neuroscience and quality structure, so I'm quite new on this.
Okay, great. All right, then we can start with the first paper. And Ishan, let's try to keep it 15 minutes, okay? So then we can have 15 more minutes of discussion. The floor is yours.
Yeah, can I share my screen?
Yeah. Is it okay?
Yeah, I'm just trying to pull it up.
Okay.
Can you see my screen now? Sorry.
Yeah.
For some reason, it doesn't let me. 1 second.
Oh, you have to put it in full screen before you share.
Oh, okay.
That's what's happening. As somebody was pointing out to me during a meeting recently, after all these years, we still don't get Zoom right.
Yeah, the
All
thing
of
is,
us.
I'm on a Linux machine right now, so it's
Yeah.
even more irritating.
Yeah.
Yeah.
All right. That's perfect.
Okay. So the paper that I'll be discussing for today's meeting is an adjunction hypothesis between Qualia and reports. This is from a paper that came out a couple of years ago in Frontiers. And let's start by raising some issues and concerns about the status quo in consciousness science, as this paper does. So the paper first discusses that one of the issues is that much of cognitive neuroscience research in consciousness has been in contrasting when people see something or hear something versus when they don't. Right? So there is this seen unseen contrast, right? Conscious unconscious contrast. And here, consciousness is treated as a binary variable, whether you have it or you don't have it. And the problem here is that it misses out on, obviously, aspects of experience. So the only thing it's interested in saying is whether it's you were aware of something or not, but it doesn't talk about how you were aware of something or what properties you were aware of, for instance, and so on. And the other concern that this paper raises about the status quo right now is when people use behavioral reports to infer what someone would have experienced, these reports are often incomplete. So let's say I show people a scene of a beach and ask them what they saw, and they write down, I saw an image of the beach. But it's not clear whether it was a pebble beach, a sandy beach, where the sun was it a crowded beach, how clear the water was, and so on. Even though that was part of people's experience, presumably, we can't directly access it because no matter how much you ask people to describe what they saw, it's always going to be partially incomplete. The other thing is it can also be inaccurate in the sense of being incomplete or slightly coarser than what they saw. And there is often the issue of many-to-one mapping. So for instance, if I show people two patches of red with slightly different saturation, people would say that they saw red in both cases, but they would have also experienced one as being darker or lighter than the other, which we wouldn't know from just a singular response of red. So the paper is about how we can still infer aspects of an experience given these concerns. And one way to do that is to think about experience as composed of relationships rather than objects. And this idea will become more and more clear as I move ahead. But let's say you have two sets. One set we can call the qualia set, which has states of experience. And you have another set, we'll call this the behavioral set, which has reports of people's experience. And for now, we assume that within these two sets, these elements of states of experience or reports are related to each other either by similarity or by an order. So what this means is that if you have a set of color experiences, they're related to each other in terms of how similar the color are, or in terms of order in the sense of whether one color is brighter than the other. And we can assume the same relationship or same type of relationship holds for the behavioral set. So your responses of red, orange, or dark gray, gray, and so on are either related to each other by similarity or by an order relationship. Now, assuming that these three conditions are satisfied, we can look at how we can map these two sets, either going from qualia to behavior, which is a response mapping, or going from behavior to qualia, which is a inference mapping, where you try to infer what someone would have experienced given a particular behavioral response. Now, when we are trying to map these two sets, which is of qualia and behavior, they can have a different degree of sameness in the mapping. So you can have a mapping of identity where each element is exactly the same in the two sets. Or you can have a mapping of isomorphism where each element might not be the same, but the relationships between each element in the two sets are exactly the same, right? Or you can have an even weaker degree of sameness, which is called adjunction, and which is what I'll be showing you in just a moment. So the paper uses an example from color and an example from real numbers and integers to make this point. And we'll try to go through both of those examples when the sets have a relationship of order. Right. And this is going to be slightly tricky because when it's a little hard to explain, and this is something I have no background in, but I will try to do it anyways. So we'll only look at the figure on the left right now. Okay, so let's say, just try to follow this figure with me. Don't like get ahead of yourself or of me. So let's say you have two real numbers and two integers in two different sets of real numbers and integers. And let's say that the real numbers are related to each other by a relationship of greater than. So we know that 5 is greater than 2.2 and so on. And we know that in the integer set that 5 is greater than 3. And now we want to map this, the relationship of this set onto the relationship of the real number set in a way for us to know whether these two sets have some degree of similarity. So what we want to do is we want to be able to draw a functor between these two elements and these two elements. So to do that, what we need is an intermediate adjunction functor, which satisfies the relationships in a way where any element that we put here is greater than this number, but smaller than this number. So what you want is a way to go, a way to create an element that satisfies the mapping which is there between these two integers in a way that this mapping holds here and here and here. Right. So in theory, you could have any element here as long as it's bigger than this number and smaller than this number. And then once you create that adjunction mapping, you can argue that the relationship that is there between these two integers is also there between these two real numbers and between these two intermediate elements and between these two elements. Right, so what you can then do is go from the relationship that is there in the integers to the real numbers. And
Ishan,
obviously,
may I just interrupt you?
Yeah.
You're saying, well, here and here, and but we're not seeing any cursor or anything. Is that?
That's odd. Okay. Okay, so sorry, maybe, I mean,
I'm following it anyway, but I assume that you think we're seeing something that we are not.
Okay, sorry. Let me see if there's a way that I can put a pointer. Okay, I'll try to use notations, but anyways, so
Yeah.
what I'm trying to say is the relationship that is described by the small g can be established, can be shown to be adjunct to the relationship of the small f by having an intermediate element, which is an adjunction of the functors capital G and capital F, such that the element in that adjunction is greater than 2.2 and smaller than 5. Right. Then we can then we can go back to the examples from color, which is more related to experience. So let's say we show people 2 color patches, which are related to each other in the same order relationship, such that one is darker than the other. And let's say that people give you responses which are either dark gray or black, or they just say that both look black. But as long as we can establish that one black to people appears darker than the other black, then we can try to approximate the relationship that was there between people's responses back to the relationship that was there in people's color experiences of one color being darker than the other. And I think one of the assumptions here is that you can't actually recover how people experienced any individual color patch, but all you can say is that people's experience of these color patches are related by the same order relationship like their behavioral reports. Right. So why is this useful? What this allows you to do is use behavioral reports as relationships to model relationships between people's experience. You could also, in principle, do it between two people, where you can try to approximate whether two different people have similar relationships between their experience given the relationships in their responses. You could also look at the same person's experience at two different time points and try to show that the relationships that people's experience had at time point T1 are the same as they were at time point T2, or they weren't, I don't know. And I mean, you can do all sorts of manipulations such that, and for instance, the paper discusses you could have cases where people are paying attention or not paying attention to to the same stimulus sets, or where their attention is divided, and then you can look at whether these relationships are similar or not. You could have people being trained, like in different phenomenological traditions, such as meditation and so on, and then see how the relationship between elements in their experience change. And you can also, one suggestion that the paper offers is you can have a more rigorous psychophysics, such that you can reduce the loss that you have in going from behavioral reports to experience. So the more number of trials that you run, the more finer discriminations that you ask people to make in their experience and so on, can take you closer to being able to approximate the more richer experience from more impoverished reports. And I mean, that is my summary of the paper. And the format of the journal club was to end with some questions for discussion, and these are the things that I could think of. So one of the questions that I had, which I was hoping you guys could help me answer, is can we actually quantify the loss that we have in making an adjunction? And if we can we quantify to what precision? So the intuition that I had from reading this paper is that you can't actually quantify the loss. And if you try to be more precise, the loss would become infinite. But I have very limited mathematical background, so I could be completely wrong. The second question that I had was, what kind of relationships are allowed? Like, I know the paper discusses similarity and order relationships, but are there other relationships that we could think of, possibly? I mean, I couldn't come up with anything myself, but I'm curious to know whether anyone else has an idea. And finally, the third one is something that I'm interested in more personally. This is the sort of thing that I do. So let me give you an example of the third point here. So let's say we are interested in understanding the experience of people's attention wavering when they focus on something. So let's say people are doing a focus task and their attention keeps getting pulled away or wavers as they're trying to focus. Let's say to ask people to tell us how their attention wavers, we give them a metaphorical or analogous way to report it. Let's say we give them a candle flame. Like, we give them an animation which has a candle flame. And let's say we ask them to adjust the wavering of this candle flame, like in this animation, to analogously convey how it is for their attention to waver. And then what we have now are behavioral reports, which are about the dynamics of some animation, and which is supposed to reflect the dynamics of their attention. Can we still do this sort of relationship mapping between people's attention experiences and their animation responses. Like what I'm trying to say is, do we only need to restrict ourselves to similarity ratings where you showed people two things, ask them to give a rating of how similar it is? Can we extend it beyond that in a way where people can recreate aspects of their experience using some metaphors? Like, I don't know, like another popular metaphor is like stream of experience. Can you show people a literal stream and ask them to manipulate, I don't know, turbulence of the stream or the flow of the stream and so on to map onto how their experience flows and so on? That's all from me. Thanks.
This is great. Thank you so much, Ishan. Actually, very suggestive hypothesis. So if I can jump right in, you are suggesting basically to sort of construct this because this approach works because you sort of construct a network of relation between objects, right? But you're saying, why do we need to limit ourselves just to words or the similarities in the similarity ratings, and why cannot we move to more abstract analogical? That would be the proposal, right? That's
Yeah.
very, that's quite interesting, and maybe, yeah, never thought about it, to be honest.
Yeah, I mean, I have like lots of poetic metaphors that, I mean, given I come from a phenomenological tradition and
Yeah.
most of phenomenology was trying to convey experience through words. I mean,
Right.
like poetry, but I mean, I'm super curious about this sort of thing. And I think this is the correct framework to be able to do something like that.
Yeah, maybe I'm wondering if it isn't it like what people normally do when they discuss, for example, I don't know, the taste of food or the wine tasting also, right? Like you do something similar, right? In
Yeah.
principle.
Yep.
So yeah, that's a very suggestive idea. Does anyone else comment on this point or any other comment in general? Pedro, I think.
Yes, I do, but okay, if nobody wants to jump in, I will say something. About quantifying the loss, well, that's a very tricky question because we're quantifying the loss of something which is not directly measurable. So we don't know what was there before we report it. So it has to be indirect, which is the whole purpose of these adjunctions. There is something, however, theoretical that you might be able to use, which is might not help you quantify, but it might help you believe that by having enough reports, you will capture everything there is to be captured in on the experience realm. That would be a kind of mathematical theorem saying that if I take all the possible functors from the qualia category, then this collection of all these functors will actually give you all the information about the original category. I mean, there are theorems in mathematics of this type. We'll say that something like a virtual space has enough points, let's say, when you have enough such mappings from this space that allow you to distinguish everything on the domain. So that's an interesting question. But it also depends on the kind of structure which you want to put on your category Q. So if it's just a category, that's not too much to start from. But categories can have additional layers of structure. They can have products and co-products and etc. And the functors can preserve some of these things. And that means you're respecting some of the structural information of your domains. So that's something I hadn't thought of, and it's well worth thinking about a little more. So thanks for for that question. So such a theorem would say, well, we can potentially know everything at an infinite limit. I know that I will eventually know everything, although I cannot quantify exactly at which point I have known more than 99% or something. So, but at least in principle, you would be able to know. So that's something to try to have in the whole mathematical apparatus. Now, what kind of relationships are allowed? You mentioned the word analogies.
Mhm.
I mean, it's interesting. There's a whole field of artificial intelligence which is called analogies. I didn't know about this until a few weeks ago. Then I was invited to participate in a workshop organized by a colleague of mine on this topic, which had a section called provocations. And he said, you should go and give a talk about consciousness there.
Mhm.
And I said, oh my God, what are you guys doing? And well, I'm finding some similarities here. So analogies are all about finding, things like strange, insights about you have something in a domain, and then you realize, oh, this is a bit like that, which is something totally different. And these people are interested in finding applications where by analogy you can construct new AI tools, etc. So these would be possible relationships, maybe, and maybe there you have some literature to look at. There's something called analogy structural mapping, which was actually developed by a psychologist called Didri Gentner. She has some papers which are foundational on this approach. Okay, that's one thing. My take on it is usually I don't specify relationships. I mean, I've been playing with some spaces of qualia where the qualia are points, and then there are these open sets which are like the physical properties. They are bits of finite information that you attach to qualia. You have a visual experience, and you can say it's red, or that it's bright, or that it was tense, or that it was short. And if you have one which has all these possible properties, that's somehow less specific than one which was very bright, very intense. So it has fewer properties in a sense. So the more properties you have, the more undefined the thing becomes, and this generates a partial order. So it's just that the partial order can have many meanings depending on what kind of properties you're using, and potentially any set of properties could be used with all sorts of meanings. Is this making any sense? I mean,
Yeah, I mean, I do get the sense that the more properties you have, you would have partial order. That does make sense to me.
Okay.
Maybe let's see if Igori and Luis also have some comment, question, or...
I have a comment that may turn into a question, because this comes from my very superficial understanding of the subject. But in regards with Ishan's last question, if we want to map metaphorical behavioral reports, wouldn't it depend on whether we can transform that into the relationship between the qualia and the behavioral response, in this case, into a mathematical function, like similarity or less than or more than? Wouldn't it depend more on that, irrespective of whether it's metaphorical or not?
Can you clarify what do you mean exactly?
Yeah, I mean, if I understand correctly, what we want is to measure the relationship between, in these examples that the paper shown, between qualia and behavioral responses. And the relationship between those, they are based on a mathematical function, if I understand correctly. It's similarity, dissimilarity, less than, more than. So if we want to map metaphorical behavioral reports, wouldn't it depend whether we can transform those reports into a mathematical function, just like?
Yeah. I see.
Is it correct, my understanding of? Yeah. Okay, that was it.
Thank you. And we have still a couple of minutes if Igor, you want to add something, or if anyone has other.
Yeah, I had maybe just some thoughts and comments about generally related to this article, because for me it was interesting to think about also a specific like analogy. It's called like map and territory analogy, and it applies to language. So kind of language is a map, and kind of reality is a territory itself. So in this case, yeah, for me it would be interesting if there are any like kind of gaps or potential mapping between the like subjective, like between the quality of experience and the language itself, because somehow language is just a kind of way of reporting, and I think the language itself is not very kind of flexible tool. Yeah, it could communicate a lot, but also I think it's kind of a limitation as well. So yeah, I just had some thoughts about relation between the language and kind of reality, and if there are any thoughts from this article on how to use this framework. Mapping this. I don't know. Is there a lot of levels how we can approach it? But it's just my thoughts. I don't know.
If I can say something, that seems to be a very fundamental question from at least since the beginning of the 20th century, because Lewis, who invented the word qualia, he wrote this book, which is about developing a theory of knowledge, in which he had qualia and he had something called the pure concepts, which were those things that could be communicated amongst rational agents. And these seem to be two interconnected levels all the time. So in his own language, he was also hinting as well, there's the ineffable part, which is the experience itself. And then there is the stuff which is represented in terms of finite amounts of information. And that's physical. I mean, finite amounts of information are things you can write with zeros and ones on a sheet of paper or whatever. And the relation between these two things seems to be at the heart of all the experimental programs that try to probe into consciousness. You have to rely on this conceptual part, language part, to make it work. So I don't know. It's clarified.
I was thinking also in connection to I know a little bit about the IIT ontology, for example, when they also try to define concepts and also a relation between them to describe consciousness. I was thinking if there are any kind of relation between this framework presented in this paper, connection to IIT ontology, if you know something.
I would say yes, but maybe this is a good time to finish the first block and start with the second on IIT, and maybe get back to this point later.
Yeah.